This is a review of some resistor addition problems if you need brushing up on this. This particular assignment is called equivalent resistance. We did do this before the break. The answer key is already on Canvas, but I'm going to walk through these step by step if you need that help. Alright, so let's start here with the first one. When you have combination circuits, it's sometimes difficult to know exactly where to start. So I always look for the simplest series only or parallel only combination that I can see. So right here I see these three, the 18, the 9, and the 6. They look to be all parallel with each other. I know they're not in series because, again, series, you have the same current is going to go through two resistors without a junction in between. So here we'd have current going through the 12 ohm resistor, and then it splits three ways. So I know none of these are in series with the 12 because there is a junction between them. Okay, so these are all going to share that current. Okay, we talked about Kirchhoff's junction rule, says the current going into a junction equals the current leaving the junction. So these three currents I know have to add up to the current through the 12 ohm resistor. So that's a little evidence that we know those three are in parallel. So now, to add resistors in parallel, we do the inverses. So 1 over the resistance equals 1 over 18 plus 1 over 9 plus 1 over 6. So if you do that and solve for R, remember that is 1 over R. So when you add these fractions, make sure you invert that. R we should get to be 3 ohms for those three in combination. So we could redraw this if we'd like. Not really essential. But I'm going to replace those three resistors with a single 3 ohm resistor. And this is still 12 ohms. Okay, so now to add these are in series, so this is easy. We just say 12 plus 3, so that total resistance is going to be 15 ohms. Alright, moving on to the next one. Okay, so this is a good example where if you look at this 5 and this 5, geometrically they look parallel to each other, you know, what you learn in geometry class. But if you can imagine current going through here, it goes through this resistor, and then it goes through this resistor. There's not a junction in between these two resistors. So that tells us these two 5 ohm resistors are in series. Okay, so the 5 and the 5 in series is 10. So I'll write that out. So now I'm going to redraw this. So I've got this 5 ohm resistor. Still have this 5 ohm here. This 1.5. And then we combine these two 5s. So that I'm going to draw that out here as a single 10 ohm resistor. This should be connected here. Okay, so now I see the 10 and the 5 are parallel to each other. You've got current coming through here, some goes through the 5, some goes through the 10. They're parallel. So 1 over R equals 1 over 5 plus 1 over 10. So when I do that, R equals, looks like 3.33. Okay, so I'm going to redraw that. So now I'm going to have still the 5 ohm here, still the 1.5 down there. And this now, we combine the 5 and the 10, so now this is a 3.33 ohm resistor. And then we've got the 5, the 3.33, and the 1.5 all in series. So the total resistance, 5 plus 3.3, that's a funny 3, plus 1.5. So the total resistance for this one, 9.83 ohms. Alright, next one. They're getting a little bigger here. Okay, so The first thing that jumps out to me is this 10 and the 5 combination right here. Okay, I see current coming in there, some goes through the 10, some goes through the 5, and then it comes back and all goes through the 4. So that tells me the 10 and the 5 are parallel with each other. You might be tempted to think, well, this 4 and the 3 are parallel, because honestly in these circuits you can imagine the current going either direction. You can imagine going counterclockwise like this, or clockwise. It doesn't matter. So if I imagine the current going counterclockwise, it splits here. Some goes through the 3, some goes through the 4, but you've got more to this side than just that 4 ohm resistor. So you might think the 3 and the 4 are parallel with each other, but there's more to it than just the 3 and the 4. Whereas the 10 and the 5, you're thinking they're parallel to each other, and that's all there is to those two. They are parallel to each other. So I'm going to tackle that first. Say 1 over R equals 1 over 10 plus 1 over 5. So that is going to be 3.33. So now I'm going to redraw this. Got the battery down here. There's the 3 ohm. Okay, so this is the 3 ohm resistor. This now is 3.33. Okay, we replace the 10 and the 5 with that 3.33. This is the 4 ohm resistor, and then this is the 3 ohm resistor. Okay, again, the 4 and the 3 you're thinking parallel, but there's more to it. Now, if I look at the 3.33 and the 4, there's no junction between it. I know these are in series. So if I add these, 7.33 ohms. So now, redraw it one more time. And again, you redraw these as much as you need to. Okay, I'm doing a lot more here than I normally would, just to show you guys the process. Okay, but if you don't need to redraw a couple of these, that is totally fine, as long as you've got a good handle on this. So now the 4 and the 3.33 combine to make the 7.33 ohm, and then we still have the 3 ohm down here. Okay, now we can look at these as being in parallel because there's nothing else going on. We've got current coming in here, some goes through 7.33, the rest goes through the 3, and then they come back together. Okay, so I'm going to add the 7.33 and the 3 in parallel. In fact, I'm going to come over here and do this. So 1 over R equals 1 over 7.33 plus 1 over 3. 2.13. Yeah, I believe that's it. Okay, so now one final redraw on this. So we still have that 3, and then there's our other one. So this is the 3, it's still the original one that was up here, and then this now is the combination of the 7.33 and the 3, which is 2.13. Okay, so then the total, we just have 3, 2.13, 5.13 ohms. Okay, all right. Remember, just real quickly, in parallel, like when we're adding these two, I know when I add these two, the total is going to be less than 3. Okay, in parallel, your total is always smaller than your smallest resistor that you're adding in there. All right, one more. Okay, so two things jump out at me in this one. I see this 6 and the 6, and they are only parallel with each other. I see the 4 and the 12, they're only parallel with each other. This whole branch is parallel to this whole branch, but we can't deal with that until we add the resistors together before we get there. Okay, so I'm going to, for this one, they're parallel, so 1 over R equals 1 over 6 plus 1 over 6. So this is going to be 3 ohms. Okay, and then for this one, 1 over R equals 1 over 4 plus 1 over 12. So this is going to be 3 as well. Okay, so now I'm going to redraw this just to clean it up a little bit. Okay, so this is still the 3 ohm resistor from right here. This is still the 3. Now this is the combination of the two 6s, so that now is 3 ohms. Okay, this is still the 2 ohm resistor that was right here, and then the combination of the 4 and the 12 is a 3. Okay, so now I see the 3 and the 3, they are in series, no junction between them. This 3 and the 2 are in series, there's no junction between them. So adding resistors in series, very easy, just simply add them. So 3 plus 3 equals 6, 3 plus 2 equals 5. I'm going to quickly redraw this. So I've got 3. My resistors are getting sloppy. Okay, so this is the original 3 ohm resistor. It's always been there. This now is the combination of the 3 and the 3, which is 6. And then this one is the combination of the 3 and the 2, which is 5. Okay, so the 6 and the 5 are in parallel. So when I add the 6 and the 5, I'm going to get something less than 5, I know that, and it's going to be 2.73. Okay, so one final redraw on this if you need it. So again, this is my original 3 ohm, and then the 6 and the 5 combine to make the 2.73. Okay, so then the total will be 3 plus 2.73 because they are in series. So here we get 5.73 ohms. Okay, that's it. Real important that you're able to add resistors in various combinations because then when we do circuits where we're looking for the current and the voltage drop across all the resistors, we need to be able to get that total resistance first. So make sure you've got a good handle on this. As always, if you have any questions, shoot me an email.